Hello everyone, welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to see and explore a very nice package called Dalex. So Dalex is a very nice library which is useful for trying to explain your model and also detect a bias in your model. So the full name is Model Agnostic Language for Exploration and Explanation. So with Dalex, you can explore your model to detect for fairness. You can also use Dalex to interpret and explain a particular model, right? Very nice. So these are the main components. So with Dalex, this is the various components of Dalex. It can be used, it's having explanations component that can be used to interpret your model and then to interpret a particular prediction or explain it. It can also be used for fairness checking, which is a very interesting concept of building machine learning pipelines and machine learning product, in which you're supposed to check for fairness and then biasness or bias within your model and your dataset. We also have Arena, which is a simple app that can be used to do the same thing but in an interactive approach. Then also have the dataset. So let's see how to work with this particular package, right? Today we'll be exploring the explanation, then later on we'll explore the fairness. But in case you want to go ahead with the fairness, you can check the links below. I have a 2 hours tutorial on fairness detection in models. Okay, so let's go back to our workspace. You'll be using Colab, and then you'll be using a different data set, right, to work on it. So I've imported our normal packages, Pandas, NumPy, Matplotlib, and Seaborn, and our machine learning packages. So we're using scikit-learn in this instance. You can also use for Keras and then SGBoost. Okay, so to install it, just go with pip install Dalex, and then you also need Plotly to help us with our plots. So let's work on our dataset. I'm going to load my dataset. So the dataset we are working on is from UCI machine learning. So I'll go back again, I'll check it out, which is UCI machine learning, and then you are working on the bank marketing dataset. So in case you don't have it, you can just check this out. So the goal behind this dataset is that we are supposed to, it's a classification problem. So the goal is to predict if a client will subscribe yes or no to a term deposit, and these are the dataset, and this is the various attribute information. So 1 is going to be for yes, and then 0 is going to be for no, right? So I've already encoded it to make it easy for us, because our main idea is on how to use Dalex to explain our model. So let's load the dataset. So df pd.read_csv, and I'm going to read the dataset. So the dataset is called bank info. It is found here. I've already copied it here, which is bank additional, which is this one. So bank additional full encoded. I've already made it simple so that we don't spend a lot of time on this. Okay, so I'm going to just open this particular data set. It's going to give us an error because of this. So in case you have any question or contribution, you can put inside the comment section below. Okay, so let's check what this data set has to offer us. So let me create more cells. Okay, so df.head. If I check it out, you're going to see how the dataset looks like, right? I've already encoded them. So we have these particular options. We have the age, we have the job, marital, all of them have been encoded, education, default. So let's check the various columns, the shape of the dataset. So df.shape, we have it as a very huge 41,000 data points. Then let's check for the columns, which we'll be using. So df.columns. And then this is going to be our column. So age, job, marital, education, default, housing. So some of these variables or some of these features can be sensitive in case you want to do or detect for model bias, right? For example, age can be sensitive, can be a sensitive group. Marital status can also be one. And then let's say income also, as well as education, can also be used, right? So all of these things can also be used can influence the model in case of biasness, as well as the gender and the rest. Okay, so our target is this. So let's copy all of this from here to be our y, right? So all of this is going to be our features. So let's go back again and let's code as my s features. So df, you're just making it simple for everybody. And then for our y labels, this is going to be for our y. It's going to be df then y. So if you plot for the class distribution, this is highly imbalanced, right? So this is going to be the class distribution. I go with df y, right, dot value count. I check it out dot, yeah, let's make it like this. So I go back with this, you can see that it's highly imbalanced. You can actually check for the distance. So dot div df dot shape, taking the first value, and then going to multiply the entire stuff by mod by 100. So if I go back with this, you can see that it is highly imbalanced, right? 88 and 11%. So the yes is 11, and then 0 means that many of them are going to say no, right? But you can actually plot it using seaborn. So seaborn, then count plot. I'll pass in my s is going to be my target, which is y, and then my data is going to be df. So you can also use seaborn to also plot it in case you want to see it in a pictorial format. Perfect. You can see that this is very imbalanced, right? But most times, if a data set is imbalanced, you must make sure that you balance it, right? There's imblend you can use to do that. You can also use some machine learning models that are very competent with imbalanced data set, like most of the tree-based algorithms, like decision tree. So decision tree classifier works very good on imbalanced data set because of the approach it goes on, as well as random forest. Okay, so let's split our dataset, and then we will build a pipeline, and then we explain. So we're going to split our dataset. So it's going to be my S-train. So I'm going to split it right by 30, 70. So that's already splitted it. Now, because the dataset is having, if you look at it, is having, some of them are not in the right range, like the duration is higher, the PDs are higher, the age is higher, so you must scale them. So we'll be scaling them together with the pipeline to make our work easy. So most of the time, it's better you use a pipeline approach, right? It makes your work easy. So build a simple pipeline. So the pipeline is going to consist of the data to data stage, which is the transformers, and then we're using the data to model stage, which is the estimator. So let's create a simple base pipeline. I call it base. Then I'm going to call it as my pipeline. So it's going to be my pipeline. The pipeline is going to take some steps, right? And then inside the steps, we're going to pick in our scalars. So let's call this standard scalar. Using standard scalar, I can also use min mass, but I prefer to use standard scalar. Then I'm just going to go back again. Scale, I'm going to specify that, okay, use the standard scalar. So standard scalar. Standard scalar, right? And then that's going to be for, this is going to be for our data to data stage, right? Then we need our model. So we're using our base model. So most of the time it's better you build a base model and then you use it to purge for your different models. So let's base our base model, which is going to be dummy classifier, which is not going to learn anything. So dummy classifier. Can't spell classifier. I don't know whether I can hear some noise behind. Apologies because of where I am. My apologies. Okay. Right, so we're using two different models. So we're using the base dummy classifier, we're using logistic regression, and then we'll be using the normal decision tree, right? You're just building three different models. So let's check for the base accuracy. So this is going to be our training. So for the base, right? So it's going to be for the base model. So since it's a pipeline, everything is going to be done as a simple one. So pipe base model, right? Dot fit. I'm going to pass in my S train and then my Y train. But it's going to build a model very fast, and then we can check for the accuracy. So let's check for the accuracy of this model. So this is going to be of our base model, so accuracy of base model. Then later we will explain it. So pipe base dot score, and I can pass in my S test and then my Y test, right? So we'll be very fast. Then we move on to the model explanation, which is very high. So this is high, but remember that the data set is imbalanced, right? So you should not be trusting this. So let's build the remaining models and then try and see how to use Dalex to explain it. So I'm going to run the two of them. So the same thing above, I'm just going to build it for the logistic regression and the decision tree. And then from there, I can just check for the accuracy of them, right? So let's check it out. You can see that the logistic regression is high and the decision tree is almost high, almost They say no, it's not the same thing because I made a mistake here. Copy and paste is bad. Okay, so if I run it, you can see the difference, right? So the loss regression, it appears to be doing well, but the decision tree is also doing better, right? But if you check the F1 score, you're going to see the difference. But let's move on and see how to use Dalex, right? Because that is the main goal of this tutorial. So this is going to be how to use Dalex for the prediction. So model explanation, right? Explanation, right? I don't know how to spell it here. So let's start with it. So it's very simple. It's having this particular API. So this is a basic approach. With Dalex, for working with the explainer model for explanation, you can explain a model and also explain an instance, right, or of the model prediction, right? And then in case you are trying to explain a model, you can check for the model performance, that is the accuracy of the model, the F1 score. You can also check for the model path, that is what are the various variables and features that are contributing to make the model performance, right? The variable importance. You can also do a model profile, right, to check for the profile, the different aggregates of the different variables and or features. And you can also do model diagnostic. The same thing you can do for a model, you can also do the same thing for the prediction. So you can also check for the different parts of the prediction, what are the different variables contributing to produce a particular prediction diagnosis, and prediction profile. So let's check it out. Okay, so I'll come back again and I'll check it out. So we are going to import Dalex. So import Dalex as dx, right? And then we work on it. So let's explore the various things we can do with this. So this would be the methods of Dalex. So ds, so dir, as we always do, ds. We're going to start just having the 4 different components. Okay, so you can see, as I said, we have the arena, right, which is the app itself for interactive explanation. We have the explainer, we have the dataset, and we have the fairness, right? Okay, so let's see how to work with the explainer. So I'm just going to go back again and making an explainer instance, right? It's going to be very simple for the model. So all of these things is going to be for the model itself, right? So the first one is I'm just going to go with this option. So I'm going to create my explainer. So explainer is going to be my ds.explainer. Then it takes some argument. It's going to take in the model itself. As you can see, it takes the model, right? So it can be any of the models, XGBoost model, it can be scikit-learn, Keras. Then you're going to pass in your data, right, which in this case is going to be our S training data, and then our Y train data, right? Then it also takes some other functions. It takes the label in case you want to give it a particular label, and the rest. So let's make it very simple. So I'm going to pass in my pipeline. So let's use the logistic regression model, or you can use the decision tree anyhow you want it to be. Then let's go for the training data, right? So S train, and then the Y train. Perfect. That is all. So this is going to create an explainer. It's going to analyze it. Then it's going to give us some very insightful information. It's going to tell you the number of rows within the particular data frame, which is this S, and the target variable, right? The various parameters, the model class, the particular type of model it's using, which is very cool. It's able to identify the model. It's very, very insightful. You can and give you some other information. Okay, so let's hope it works perfectly well. Okay, now that is the first step. So the next thing is that you're going to try and see for the model performance. So let's check for model performance. So for the model performance, you want to see how performant our model is. This is going to include our scores, accuracy score, F1 score. So it's going to be very simple. So sp.model performance, right? And by this you can get the model performance. It's going to return as a data frame, right? So this is it. So you can see that it's logistic regression model. As you can see, this is a recall, this is a precision, and the F1 score is 51, right? You can also see the accuracy and the AUC. Very simple, out of the box, right? You can also do this way. So this is another way you can also do it. This method 1. Method 2 is you can also do it in this particular option. This dot result. If I go with the dot result, it's also going to return the same thing above, right? Either you use this one or use this one, right? And as you can see, this nice logo, that means that you can convert it to a data frame and do some manipulation. This is coming from Colab, which is a very nice feature. Okay, now this is as a data frame straight away. Okay, so let's move on to the next step. So we have seen how to do model performance. Let's check for the variable importance. So I'll come back. This is going to be my variable or feature importance. Which of these features are contributing, right? contributions to the model, right? What are the various contributions of the various features or variables towards the model? So that is very simple. So SP explainer model part. I go with model part. Now it's going to return the results for us. Take some time for it to analyze. So in case you have any question or contribution, you can put inside the comment section below, and apologies for any inconvenience. Okay, so you can see that this is it. So this is going to show you the various variables within our data set together with their dot loss, right? How much they are contributing, and then the label, the particular model, right? Very nice. You can see all of them. This is the same thing you could have done in case you're using Select K-Best. You can also use Select K-Best to help you with this, right? Or extra tree classifier. So let's see this particular one. This is a table. In case you want to see it in a particular diagram in a plot form, this is how it's going to be. So this is going to be model variable importance via plot, right? So to do that via plot, just go with the same thing. So explainer dot model parts. This is where you may need plotly, right, extension. Then just go with my plot. If I go with plot, this is going to plot it perfectly for us. Hopefully the plotly is able to work, give us a nice plot. Sometimes in case you are working on a system, your extension, you need to install your extension, plotly extension to allow it to work. Okay, it worked inside Colab, right? So in case you don't have the extension, just install plotly extension. Okay, that is something very simple. So you can see from here, this is a very nice plot. I prefer the plots than this one but this is very self-explanatory. So from here you can see that the employment variable rate is contributing more than any of the different variables, followed by duration, and followed by the cost price and the P days, right? Very nice. So these can show you how much each of these individual features, each of these individual variables are contributing towards this particular model, right? Very nice. So it's very cool. It's also interactive because it's plotly. Now let's move on from there to the next one. We can also explore more about the model, not just the variable importance, but explore more. So I've seen how to do model performance, model parts. Now let's see how to do model profile and then model diagnostics. So the same way. So this is going to be model profile. It's going to be my explainer dot model profile. You can also plot it with it. With the exception of the performance, the rest you can plot. So it's going to be using ceteris paribus. That is what will be. I don't know how it is in Latin. That is what if, right? When you pick a particular variable out. So that is it, has finished calculating them. So sometimes this is okay, but you may want to see it well, right, in a plot. So let's check it out. So this, to plot it, is going to be plot for model profile. Going to be the same thing. So explainer dot model profile. The API is very simple. I think that is the future of data science, making a simple, consistent API. In case you're working in R2, you also use the same approach. So take some time for it to run. I wanted to know in the comments, do I actually speak very fast? Anyway. Okay, so that's finished, right? So it is able to analyze it and give us some insightful information about what our model is doing behind the scene. So you can see it's going to pick each of the variables, each of the features. It's going to bring out this particular plot. So as the apologies, this is going to be the aggregated profiles, right, for that particular model. And as you can see, it's going to pick each of the variables and we scale them. Because we scale them, that's why some of them are not being shown well. But if you had not scaled them and it was a different data set, you could have seen the relationship very well. But this is also insightful. So as the age increases, you can see how it's influencing the prediction to be 1 or to be 0, to be yes or to be no, right? So as it goes, you can see that it's going a bit. There's not that much changes, right? You can also see it for the rest, for the various features, right? And the reason we are seeing all of them as a straight line is because we scale them, right? If you had not scaled them, you'd have seen the difference between them. Okay, now let's move on from there and then let's see some model diagnostics, right? So it's going to be the model diagnostic diagnostics. That's going to be the last one. So explainer.model diagnostics. Can't spell diagnostics. So that is the next one. That is going to be the last one. So explainer how do you spell diagnostics? Diagnostics, right? Then you can just go with .result. Without the .result, it's still going to come. Hopefully I did not spell it wrong. Perfect. So this is going to be a very nice plot. Very cool. So that is how to use Dalex to help you understand your model, to explain what your model is doing behind the scene. So we have seen how to use it to see the variable importance, right? The accuracy and the performance of the model, the model profile, the aggregated profile for each and every of the variables, and the model diagnostic. And let's move on and make a prediction and use Dalex to explain that particular prediction. Okay, so I'll come down here. You can also do the same thing for the decision tree classifier. So let's come back here and then let's make a prediction. So make a prediction and then we'll be explaining that particular prediction. So I'm going to pick a particular dataset. So let's go to example 1. Then I'm going to pick from the test dataset, so test.ilog. Let's pick number 0 or number 7, any number. So let me try it and see first. So this is what you are picking, right? So it's wrong. It's supposed to be s_test. So let's check it out. So this is going to be our the variable that we want to predict, right? I'm just creating a random sample. So this is it. Perfect. So let's see the expected result. So this is going to be the expected prediction based on the, this is the same from the s test. So this is going to be y test.ilog 0, right? We pick 7, so we must also pick 7. Yes, 7. So let's check. So based on the variables above and the features values above, this is going to be y test. Okay, so this is going to be a yes, right? So based on these features, it's going to be a yes. Now let's see whether our model will be able to predict it as yes. This is for the model prediction. So we'll be using all of the different models. So pipe, let's use logistic regression dot predict, and since this is a data frame, we need to put inside an array like this, right? And I do the same thing for the rest, right? So let's check it out. So we are checking for the logistic regression and then decision tree. Both of them predicted it to be 1, right? I mean that our model is actually doing well. Now let's see how to use Dalex to make a prediction and explain that particular prediction. So the requirement for working with Dalex for prediction, this is going to be the requirement, is that you need to make sure that you are using a data frame or an NumPy array, right? Most of the time data frame is preferred, so it's better you convert it to data frame. So let's convert our example 1, which was this, into a data frame before we can use Dalex to explain the prediction. So this is how it looks like, right? So we are going to convert into a data frame. So we can just do it like this. So let's go, that's my sample, which is going to be my pd.dataframe. Then I'm just going to go with my example 1. Then let's transpose it, right? So if I look at it, it's going to be 1 line. I'll check it out. You can see that it's 1 line. So this is how it's supposed to be, right? It's supposed to be in this particular format. That is how Dalex understands it. Perfect. And now let's try it and make a prediction. So it's going to be my esp.predict, right? The esp from the explainer we did earlier on, which is from this one, the same one we have been using earlier on. Yeah, this one that we made here, this explainer. This is the same thing we are using because that's actually built using the same model to make a prediction from that, and then we explain that particular prediction. So I'll come down and then I'll just go backwards. So predict, then I'll pass in my value, which is my sample. So let's check it out. So perfect. This one gave us 0, 1. So most of the time this is very precise. The reason given as this 0, 1 is 0.6 is that this is, you're going to round this one, right? You round this particular one to the nearest. So if I round this value, then I'm going to get that particular value to 1. That's why. So that means that it's actually accurate. So I can just round this to this, or use argmax anyhow you want it to be. It's going to be 1, which is what our two models predicted, right? So it is 1 1, and that's the actual, as you could see from here, right? So our model was able to predict well, as we can see. Now let's see how to explain it, right? So we'll be using Dalex to not just make it a prediction, but explain the various parts of the prediction, right? Why it is making that particular prediction, and do the predict profile and then prediction diagnostics. So this is going to be the predict parts, right? So it's going to be my example, explanation. It's going to be my ESP. See what I did? ESP.predict part, and I'm going to pass in my sample, same data frame. So it's running it, I'm going to analyze it, and now I can check the result from it. So let's check the results. So it's going to be my explainer nation, right? Dot result. Without it's an attribute, not a function. I'm going to bring the data frame. So this is going to be the explanation of the result. So the variable name, the variable value, how each of these variables are contributing cumulatively, their contributions to give that particular prediction that we have, right? So let's see the plot. You can actually plot this one out. Most of the time it is advisable that you plot them. So to get plot it, plot explanation of prediction. So to be my explanation dot plot, and then that is all. Voila. So it's going to give us a very nice plot, as you can see. So this is a very nice library. Wow. It can also, with Dalex, you can also use, as you can see, this one looks, if you are familiar with the different libraries for model interpretation, this one looks like Sharp, right? So you can actually use Sharp to do the explanation. You can also, using Dalex, you can set the default from the default to Sharp or Line, right? So based on the model, this is the model breakdown for that particular model. You can see the various contribution, right? They are providing to make that particular prediction as we saw it to be, right? Very nice. So the blue is the positive contributions, and then the pink one is the negative contribution, right? Not necessarily negative as in negative, but yeah, all of them are negative. As you can see, they are negative contribution. That's which is pushing it away from what we expect it to be. Okay, now let's move on from here and do some model profile for that particular explanation. So this is going to be prediction profile. So the same thing we did, you can just go with explainer. So let's call it as my predict profile. So to be my ESP.predict profile. I'm going to pass in my sample. So this is also going to do the same thing, and then you can also plot it out. So maybe another time we'll go more into fairness, but the fairness is a quite interesting topic. There are several libraries. We have a lot of libraries like Fairlearn, Fairness, FairML. We have IBM's A365. We have Dalex. There are a lot of libraries in case you want to do fairness checking. Okay, so that's finished computing. Now let's go on and then check for it. So predict profile dot plot, and now we can see the plot of it. Perfect. That's finished. So you can see the various plots, right, for each and every of them, right? Very cool and very nice. So that is something very nice about this wonderful package. It gives you a lot of insight, right, within your model, right, as you could see how it's going, which of them is contributing to produce a particular prediction. Okay, so thank you for watching this tutorial. So in case you have any question or contribution, you can just put at the comment section below. So the basic overview of using Dalex is that with Dalex you can be able to use it to check for, explain and interpret your model, to do fairness checking, which we have not covered. You can check the links below for it. There's also the arena and dataset, and then this was what we did for the explainer. So with Dalex you can explain a particular model to check for the model performance, the various variable importance, the model profile, model diagnostic. And also you to do the same thing for a prediction, a particular instance of the model, right? Prediction, the prediction part, prediction profile. And then it's very simple. So all that you need is just to install it, and you pass in your model, right? So it is model agnostic, so it can explain any type of model, tree-based models, linear models, any kind of model, deep learning. So the most important thing is you just go with explainer, you specify your model, and then your training data, right? And then your labels. That is all. Then you can just move on with the various things. So thank you for watching. See you another time. Stay blessed, and don't forget to check the links below for more, and then subscribe to this channel. See you another time. Bye.